Hello, everybody. We're going to be working on the Unit X flowchart fertilizer problem tonight. You'll notice that there is a document attached to this assignment that's really important that you download and open up. So this is a Word document. And basically what this is a very typical type of programming scenario that we'll often encounter. And yes, I will zoom in. And as you take a look at this, here's what I will tell you about this problem. We've been teaching programming here at Gateway for quite a long time, and in several of our different disciplines, we teach people how to program. In our software development program, we teach people an intro language called C#, using a product called Visual Studio from Microsoft. And before they start to code, just like you guys, you need to learn about problem solving a little bit, pseudocoding and flowcharting, because it's really kind of a necessary step as a precursor to solving any programming problem. Now, this is an exercise that we do in our software development program, in which the students originally are just given the verbal description that's here, and then they have to come up with the pseudocode, then they come up with the flowchart, and then they actually write the program. We will not take it that far. I just want to let you know. The pseudocode is already written. We are just making the flowchart because that's an important piece too. All right. So just to kind of reiterate what this situation was, there's this guy, lawn care guy, whatever, and he needs to buy some fertilizer to put on somebody's lawn. And he pulls out his handy tape measure or whatever, or walks it off or whatever, and figures out that this lawn is, hey, thankfully perfectly rectangular, so really easy to figure out the area of the lawn. It happens to be 30 feet wide by 50 feet deep. When you multiply that together, you get 1,500 square feet. Then he looks at the jug of fertilizer and it says, I need 1 gallon of fertilizer for 9 square yards of grass. Okay, so now we have a problem right there right away. One measurement square feet, the other one square yards. Right. So what does that mean for us? I mean, so from a problem solving standpoint, now you got to start to maybe even think about, and you might do this, right? Maybe this is the way your brain thinks. I might draw a picture to help me out. And for silly as that sound, it really is pretty effective. And so I might draw a square and then think about, for example, if this is a square yard, well, I know 1 yard is 3 feet, right? So I could take the one edge of this square yard and break it down into 3. And then I could take the other edge and break it down into 3. And then I can very quickly figure out that 1 square yard is equal to 9 square feet. And so there's a conversion that happens here. Now, maybe you don't have pencil and paper. Maybe your brain doesn't want to think that way. And I get it. Some people don't want to even think mathematically, but you kind of have to for some of this stuff. And so where would you figure out how to convert from square yards to square feet? Well, you know what? There's this thing called Google. And yeah, right. You guys should chuckle because it really is kind of like that, because you can just go to Google and just type convert square, let me go type it right though, square yards to square feet, and see how it comes up. And of course, they have an on-screen calculator. Thank you, Google. And so I see that 1 square yard equals 9 square feet. Perfect. I did it right? But what if you're going the other direction? What if you have 1 square foot equals 0.11 square yards? So one little box equals 0.11 square yards. I'm not sure which math is easier, but if you look at the document and start to read through, so John says he first has to figure out how to convert square feet to yards. Well, we kind of did that. And then divide the total square yards of the lawn by the coverage amount indicated in the bottle of fertilizer. He must also make sure he buys at least enough to cover the lawn, so he doesn't fall short, and the extra fertilizer can be saved for the next time. Okay, so he didn't bring his phone with him, but he does have a calculator so he can do some of the math. But he needs to figure out the algorithm or the method or the sequence of steps, once you hear all those terminologies, on how you do that, right? And so he started with what we kind of did. We know that 3 feet equals 1 yard. and that a square yard is 3 feet times 3 feet, or 9 square feet. That's how we get there. And that gives us a very simple equation. 1 square yard equals 9 square feet. To simplify the formula, we can enter square feet and yield square yards. We need to get rid of the 9 on that one side of the equation by dividing both sides, and then you end up with that 0.111, just like Google's on-screen calculator did, right? And so you can run the math a number of different directions, but just because you're given this information doesn't mean that you're going to be multiplying by 0.111. I mean, and this is really kind of the mystery of this problem, is how you view the problem and what approach you're bringing to it can make the math either complicated or simple, depending on your mindset. And so my job is to point out the clarity of the mindset. And so this is what the students are originally given, and then they're asked to create the pseudocode. And so that it kind of mechanically goes like this, you know? So the problem ultimately is, how many gallons of fertilizer should I order? That's really the problem, okay? And so the first thing he does is he gets the length of the lawn, then he gets the width of the lawn. Those are inputs. Those would be in parallelograms, right? Input from the user. Then he takes the information that he knows, the basic formula that lawn area equals the length times width. And I want you to notice that the thing we're trying to calculate in the equation is placed on the left side of the equation, because that's how we write program code, right? So we take that formula, we plug in the numbers, so we ultimately determine that the lawn area is 1,500 square feet. Now we need to convert to square yards. And so what's the process for doing that? We divide the lawn area by 9 to determine that. So here's the equation for that. And you notice lawn area divide by 9. And then we plug the numbers in, and that yields 166 point whatever square yards. Now to determine how much fertilizer we have, because now we're dealing in square yards and the bottle is dealing with square yards, now we're going to divide that once again by 9. Here's the actual numbers, and here's the resulting math. So ultimately he needs 18.5 gallons, walks into the hardware store, and the guy's like, you know what, we only sell whole gallons. You know, so how many gallons does he buy? The answer ultimately is 19 to get the job done, because he doesn't want to have to stop and go back to the store and get it, right? So 19 is the answer. So that's the algorithm. And I want you to think about this, the steps it takes to get the right answer. Now, if we take this algorithm and apply it to any other lawn that is rectangular in shape, we should get the right answer. If the problem was solved correctly, we can now take the solution and apply it to any situation. This is the beauty of creating a solution like this. So now our job is to convert this into a flow chart. I'm going to use Microsoft Word to do this action. So I'm going to create a new document here in Microsoft Word. You can also use Google Docs, and then when you try to add the shapes, it'll bring up the Google Draw program. But I strongly, strongly, strongly suggest that you use Microsoft Word to do this action. Now, I'm doing this on a very simplistic level. I'm not trying to use any automatic tools. I just want to show you that manually, it's very not difficult to do. So follow along with my actions as best you can. People that are here in the lab, Microsoft Word is loaded on these desktops. If you're on your own machine and don't have it, you might want to consider using the desktop that's sitting there, or go to Google Draw. All right, so here in Word, I'm going to go ahead now and basically go to the Insert menu, and I'm going to choose the Shapes option. Now, I want to kind of warn you too, that if you're like seeing Word in a not full screen view, it is possible that that shape icon kind of gets buried in the submenu. So just, my recommendation is maximize your screen if you can. But that typically appears in like the third little panel. Right? So choose the shapes icon. And then I also want you to notice that they have like these different areas here, right? So some of the shapes we need are in one area, some are in a different area. But if you go way down the list here, you notice all the flow charting shapes are kind of gathered together in one area for our convenience. Another thing that people will say to me is, aren't there better tools for flow charting? Absolutely. Absolutely. But you know what? Who's got time to like go out and download Microsoft Visio, which costs a fortune, or some other flow charting software? Word's got the stuff we need. We'll just use this. This is the only flow charting assignment you have, folks. So, you know, aside from the extra credit. So let's not like get special tools. Now, if you guys remember, the first step in a flow chart or pseudocoding is to do a start and a stop box. And I don't know if you caught what icon I grabbed, but there's a shape here that's a terminator, and it looks basically like a rectangle with rounded ends. You see where I'm hovering over it, and when you hover over it, it's called a terminator. Perfect for start and stop, right? Terminal start, terminal end. Right, so I'm choosing that shape, and now I'm going to come up here. You see my crosshairs change to a plus, and I'm just going to draw that in, and that is not the shape I chose. So didn't I tell you people make mistakes with, you know, this stuff? So let's go back and do that again. Flowchart terminator, drawing it in. There we go. All right. Once you draw the shape in, so you drag, click, drag, release, make it whatever size you want. If you don't like the size, you can grab little handles here, make it bigger, smaller. But once that box is active and you can see the handles around it, you can just start to type into it. So first thing we're going to do is start. Now, you notice my text is cut off a little bit, so I have to make it just ever so slightly taller. Next thing we want to do is we want to show the direction of flow of the instructions, and so we will need an arrow. And you notice how the little panel just stays up here, and I see an arrow there. I'm just grabbing it right from the panel because it's right there. Why not, right? And so I'm just going to draw an arrow straight down. Now it's a little bit off on an angle, and I want to get it straight, and it's really hard to get it straight. There's a trick to get it perfectly straight, by the way. Just hold on your shift key, and it makes it straight. Isn't that cool? I don't really care if it's straight or not, honestly. Just for the record. Now I'm going to kind of like split screen myself here a little bit, just so we can kind of look at the pseudocode version of this and the actual document at the same time. And the first thing I see here is we need to get the lawn length and the width from the user. If you remember your shapes from the unit folder, the parallelogram, so a rectangle with the sides tilted on an angle, are the user input and output boxes. And so we're going to go back to our insert menu here, go to shapes, and then I'm going to find the parallelogram, which is the fourth one in the flowchart area. So we're going to draw this in, and then I'm going to type basically the words that are already there. Get lawn length. And I did type that word, but it disappeared because the box wasn't big enough. So I'm just adjusting the box. And I want you to notice you can move this stuff around too. You can use your keyboard, arrow keys, or your mouse. Then we're going to drop another arrow in. So go back to the shape palette, find an arrow, straight down. Doesn't have to be super long. And then I'm going to create another parallelogram to get the other piece. Yeah. And you notice the second parallelogram is probably a little bit better than the first, you know, and that's kind of how it goes sometimes. But often you can correct them too, so don't worry about that. Once you're clicked in, you can type it in, get lawn width. Okay, Jill, I see your question about the shape for manual entry. Where do you see that one? You're talking about, is it this one?
No, farther over. It's the next to the last one. That one.
Yeah, that's used in special circumstances. So like if you normally get an automatic value and then in this circumstance you're overriding the automatic and using a manual input instead, it's to show an override of an automatic function.
Okay, so wouldn't it be the the person manually entering it?
Well, it would be a person manually entering it, but when we do manual input relative to programming code, we're thinking more about hard coding a value as opposed to feeding in a variable. That would be the better example.
Okay,
Right. Yeah, and I'm not really happy with the shape of this parallelogram, honestly, so it's, you know what, it's really bugging me. I'm gonna delete it, and I'm gonna show you one trick you can do, is you can highlight one that you like, Control C to copy, click off of it and paste, and then just move that one in and change the words. Just so you know. So that's absolutely possible. All right. Now we need to get the calculations in there, and we're not looking for the numbers that he found on this job. We're looking for the generic formula that help him determine that. So the generic formula is actually this: the lawn area equals the lawn length times width. So I'm just going to copy that right out of the document. I'm going to add another arrow here to the shape. So there's my next arrow. And now I'm going to come back and add a shape for a rectangle, because this is a calculation. It is a background processing steps the users do not see and frankly don't care about. And then I'm going to paste my text into it. Didn't fit, so I'm making it bigger. I'm kind of moving it over a little bit. So that's a background processing step. Remember, I'm not interested in the values for this job. That's not what solves the problem. I'm interested in the formula that gives me the right answer. Right. From there, the next thing that we need to do is come up with the formula that gets us to the next part, which is to determine the square yards. And that formula sits right here. The square yards equals the lawn area divided by 9. So I'm copying that text, once again inserting an arrow, and then a rectangle. And I learned my lesson, it should probably be a little bit larger than when I'm making it. And I'm just going to paste my text in there, and there's my square yards. Right, we know we're going to need another arrow here, so let's just go ahead and grab that and drop it in. I'm scrolling down the page just a little bit here. And then what is our next step? These are hard-coded values. That's no good for us. This is just relative to that job. Determine the number of gallons needed by dividing by 9 once more. Well, here's the formula for that. So the number of gallons equals the square yards divided by 9. So we're going to copy that text. We're going to insert the rectangle again. Once again, background processing step. Math is always that, typically. And there's the step. One more arrow. Well, maybe 2 more arrows. Straight down. And all that's left to do now, we will have the right answer after completing this math, is to put it back up on the screen. That's a user interaction step. So I can take one of these boxes up here, Control C, click off of it, Control V to paste. I think it went somewhere. Okay, maybe not. Let's try that again. Control C. Control V. Oh, I see. It's putting it way up at the top. We're going to move it to the bottom. And instead of saying get lawn height, what we're going to say is display number of gallons needed. And that's cutting off, so I got to make it a little bit bigger. There we go. And then finally, one last arrow to take us to the stop or the end of the program. And we could just copy the start box here. Doesn't want to move fast, but come on, let's go, Word. And then we're just going to change this verbiage to stop. And then I'm going to do a little bit of a zoom out here, folks. And here is the completed fertilizer problem as a flow chart. Now here's the significance of this. And I'll answer your question in just a second, John. So the thing that's significant about this is this set of steps can now be applied to any lawn that is rectangular to give you the amount of gallons that you need. And I might say here, if you really want to be, I guess, really proper about this, you might want to say number of gallons needed, and then you might have a parenthetical fractional amounts rounded up, and you can't see that because I didn't make it big enough, but you can make little adjustments. I mean, that's technically the correct way to do it because, you have to have some stipulation in there to round it up. And I suppose you could make that a background processing step in all practicality. So this is the solution for the fertilizer problem, folks. And what we really have created is an algorithm. And this is a really key piece of terminology here. An algorithm is another way of saying a series of predetermined steps that solve a problem. So whenever you hear that word thrown around. All right, I'm going to stop the recording. And